Continuing with the PDP-1104 and PDP-1134, in this video I'm going to have a look at trying to apply power to these things. So first of all, the 04, and what I've done is unplug the power supply connectors from the supply to the back plane, because I want to be able to get in there and probe the voltages, and to keep things under control I've tied up all those loose wires, the ground wire there and the wire that goes to the bootstrap terminator board, and I've heat shrunk its terminals so that that won't be causing any problems, and we'll leave it like that until it's needed, which leaves this 230 volt American plug, which is nothing at all like an Australian 230 volt plug. But I was pretty sure that I had a connector that would go into with the PDP-1105 that I have, and I just had a look at the rack that it came in. It's not a deck rack, it's a great big super heavy thing, and at the bottom of that was a couple of these things, which are an H777 power control, and the sockets on it accept this plug just fine, and it has a Australian plug at the other end of 4.5 meters of rather heavy duty cable, so that sorts that. And so I was pretty happy about discovering that, and even more amazing was that when I went looking for a manual for it, there was one on BitSavers, which has so many manuals and a lot of deck manuals. So I've even got the manual for this thing. So basically what happens is the power comes in on a cable, goes to these indicators, and then to a circuit breaker, and then to these unswitched sockets. It also goes to a relay which connects to these switched sockets, and the relay is controlled by this switch, these connectors, and a thermal over temperature switch inside. But for the moment, just to get this thing powered up, I'll just be using the unswitched connections. But before plugging this in there, I'm going to stick some bolts into this and make sure that this doesn't blow up before we connect that. Forgot to mention I also unplugged this remote power cable from the power supply. It may be necessary to jumper something into there to get the power supply working. I'm not sure of the details, or if this is just output, I'm not 100% sure, but until I know otherwise, I'll leave this out. Less wires flapping around. And because of this power cable coming in the back here and an earth terminal over there, I'll sit that on a block of wood to stop it rolling around the place. That should be off, I think. I've got the variac there, and we'll monitor the voltage coming out of the switch sockets. Okay, applying power. Start off nice and low. And nothing's coming out because the breaker's not on. Right, 60 volts, so obviously no short circuits in there. Take it up to 240. Actually, it's more like 250 around this place. So 251, and the indicator lights are on the H777, and they're before the circuit breakers, and they're in series, so I guess they're 120 volt lamps. Yeah, so this thing seems like it'll do what we need. Just one more thing, I wasn't watching to see if any current was being drawn, so let's just make sure that none is. indicators start coming on at about 190 volts. Tiny bit of current being drawn. I guess that would be through the EMI filter that's on the input to this thing. At 250 volts. I imagine that's okay, 1.2 watts going into the filter. Yeah. Now both of these computers haven't been turned on in probably 20 years, so I think it would be a bit rude to just throw full voltage at them. So as I said, I was going to increase the power gradually, the voltage gradually with a variac, but I thought I'd just have a look inside this power supply first, and I've already taken the screws out for this MOS power supply module, which gives plus and minus 15. There's 4 screws, 2 there and 2 down here. There's a ribbon cable goes over to there, and a mate and lock goes here. And it's worth doing because there's a lot of dust collected in there to get out, and I want to do this. I still can't get to the main filter capacitors because I'm thinking maybe I should disconnect them and reform them independently of turning the power onto this thing. Measure their leakage and try and get an idea of their ESR. A bit of corrosion in there. Big crowbar thyristor, a bit corroded too. So looking at the manual, it seems that the best approach is to take the power supply out, which I want to do to clean up the console end of things, and also this wire has been routed inside the ribbon cable, which looks wrong. So yeah, if I take the front console off, which I have to loosen anyway to get the power supply out, then I can clean up what's in there and fix up this ribbon cable as well. Get this out, have a look underneath at the filter capacitors. So I'll do that. So taking off the 4 screws that hold the console to the chassis, we can then rotate this up. I'll undo the earth there. I think I'll take the console, those 4 screws out to get the console off, to unplug the ribbon cables and these things here. Take the earth out, take these off. To get the ribbon cables off, I think I'll have to undo these, looks like 5 screws to get the PCB off. So that's what I'll do next. Well, sort of almost. Going to take this filter, which no longer has any stuff in it because it crumbles to buggery. I might try and find something to put in there, some sort of foam. I've still got to now do something about the power wires to the fan for the card cage and disconnect that earth wire at the back that I zip tied onto the chassis, and then I think I can get this out. Now the earth at the back wasn't this one that I had tied to the frame. It goes to the same lug as that one does, so I've got to undo that lug, and then now that I've undone the fan wires at the front, this power supply will finally be free, I'm very sure. So there it is, the H777 power supply out of the BA11-L chassis. I think that's what it was, BA11L. Oh look, it's okay. Now some screws under there to get to the underside of the 5-volt regulator, this board. So that's next. Maybe I could just take that PCB off and get a bit more freedom with these wires out of the way. But I'll just take the cap off. See if I can just take the caps off this way. I've heard one instance of this going bad, so I'll try and that can be unscrewed with 2 bolts as well, so I'll take him out and check him as well. Pretty easy. And finally it's free. And I should be able to now get at the bolts on those capacitors. So 2 bolts holding this capacitor to the circuit board, and then loosen the clamp and this guy should come out. has to be tested. Now I can get one of the caps out. Seems to be some smooth leaking out of there. We'll find out. Give it a clean, see how it behaves with some bolts on it. Yuck. So yeah, that capacitor's looking a bit suspect at the moment. I thought this was interesting. This cap, which is looking decidedly sus, still has some voltage on it after all these years. 55 millivolts, 56. The big caps didn't have, or they had like 3 or something, less than this. Pretty amazing, so maybe there's hope for that after all. But for these guys, I've got my long serving and quite reliable and handy, though nothing special, bench power supply. And I'll set this up. I'm going to start off with low voltages here and gradually wind it up through a 500 milliamp ammeter in series with 15 ohms, and we'll watch the voltage on the cap as well as the current through the meter. Okay, we've got the ammeter, the resistor and the capacitor in series running off this power supply, and here we're monitoring the voltage sitting across the capacitor. I'll just wind it up and we should see the current go up as it charges and then fall back to nothing as it, and if it doesn't leak then it should fall back to 0. Okay, winding up some volts. Let's just take it to 5 volts first. You see, every time I take it up, it moves a little bit and then drops down as it charges the capacitor. So we'll get 5 volts on the capacitor, ish, and no current. So make it 10 volts. And I'll leave it there for a little while to get him used to having some volts on him. Then we'll take it up further. It's been on about 5 minutes, so wind it up to 15-ish. Current meter lifts a little bit. Leave it at that for a couple of minutes. Alright, let's go up to 20 volts. Ish. Now this power supply can only go to about 35 and they're rated at 50. I'd like to take them to say 45, so I'll get a battery and put that in series with this guy once we reach the limit of him. I'll leave it on 21 for 4 or 5 minutes. Next is 25 volts. And moving on, go up to 30 volts. And I'll leave it there for a while I go and do a bit of shopping. Okay, back from the shopping, and let's knock this all the way up to 35. Ding. Nope, not even 35 there. Okay, I'm going to have to introduce the battery pack. I'll get that set up in a minute. While I was out, one of the places my adventures took me to was the fabric department of Spotlight, where I got some of this wadding, metered by half a metre, cost about $8, and I'm thinking that will make a pretty good air filter, even if I one layer, maybe 2, doubled over, and then just use cotton thread to sew it onto that so that it doesn't have a tendency to come out. Maybe only 1 layer, and it's pretty fine stuff, so it should let the air through quite well and stop a lot of dust. We'll see how it goes. Okay, the battery pack's in series now, and I've dropped the power supply down to 14 volts because there's 16.8 in the battery, which gives us our 31 that we had before. So now I can wind this up to 35. That's the theory anyway. What's going on? Something not connected. Hang on. Alright, culprit found. These shitty bloody clip leads. I don't know why I buy them. They always stuff up. Right. So now I can wind the voltage up on the power supply to take us to 35. Leave it there for a while, and then we'll go to 40 and 45. I won't take it all the way to 50. Yeah, 45 is good enough. When it's operating, there's something like 38, 40 volts on here, so 45s should be ample. On to the next step, and take it to 40. And I tried attacking the rusty smooth, which seems to be only on the outside, so I don't think it came from this. This capacitor might be okay. A bit of vinegar got rid of most of it. The persistent bit wouldn't go till I hit it with some CRC, but could be okay, that thing. The rust might be just some water ingress that just rusted some of the metal work and didn't really do any damage to the electronics, hopefully. Oh well, we'll sit at 40 volts for a little while. Moving on to the next step. 45. And that's been about half an hour on 46 volts for half an hour, and we can see that the charging current is close enough to zero on this meter. So what I want to do now is swap this 500 milliamp meter and 15 ohm resistor for a 50 microamp meter, which is what, 10,000 times more sensitive, and replace this with 100k, so we can measure very small leakage currents. So after a few screw ups, I finally worked out what the hell I'm doing, and we're looking there at the voltage across the capacitor, and this meter is in series with the power supply and the capacitor and 100k. So it takes 5 volts difference between the capacitor and the power supply to knock this over to 50 microamps, but we're getting 5 microamps. Now I suspect that's just because I've changed the voltage and it's still charging this thing up. So if I wind the voltage up a little bit, then of course we get more current to charge the capacitor. Let's set it to 20 microamps. As the capacitor charges, that should drop. How long should it take? Not sure, just off the top of my head. And of course this is also measuring the current drawn by the multimeter, which is 10 mega ohms. I'll work out what that should be. 10 meg, 42, 43 volts, should draw about 4.27 microamps. So what I want to do now is disconnect everything from the capacitor, noting the voltage, 45.2, and give it 10 minutes and see how much it's dropped due to its own self-discharge. So disconnect everything from the meter, 45.2 volts. Nothing connected to the cap now, and I'll come back in 10 minutes. Okay, the capacitor has been disconnected from everything for 10 minutes, and it was at 45.2 volts before we disconnected, so let's see what's on it now. It's dropped 1.4 volts. Is that reasonable? I think it is. It's so damn low. I'm calling this a good capacitor. Alright, for my next trick, I'm going to disconnect everything and discharge the capacitor through 15 ohms. Might be a fair bit of current. The resistor's getting warm, but no sparkies. Anyway, I think that's low enough that I can try my little multimeter. I haven't got a proper ESR meter. This thing measures ESR and it I think it can go to 10,000 microfarads, so this might be a bit out of its range, but let's see what happens when we stick it on. And it takes a long time to test big capacitors. 29 millifarads, about right, should be 24. ESR, bugger all, that looks good. Just for fun, I'll stick it on the other capacitor which has not been touched yet. Make sure it's discharged. Ding. And different connector. Able to connect to the capacitor more better. Not sure what happened there. This thing decided to go into self-test mode for some reason, but I'll try again on this capacitor. Once again, big capacitors take a long time to test. 24 millifarad, the other one came out as 29 millifarad. Let's see what this one comes out as. 27, pretty good. ESR, bugger all, looking good. I'm still going to go through the reforming process on that one, just to play it safe. This little guy, see what he says. Should be 3900 microfarad diode. That doesn't look good, does it? Try again. Connections not through the bolts, straight onto the aluminium. That's better. 4000 microfarads. It's pretty close to 3900, but the ESR is a little high. So we'll see if reforming process on him does any good as well. So here we are. The next day, and the sun is shining and the breeze is blowing and the trees are moving, and we get this. Just have to put up with it, I'm afraid. The little 3900 microfarad capacitor has been on reform all night. I charged it, I built up the voltage gradually over an hour or two to the 6 volts, which is its rating. And it's been sitting on that for at least 20 hours. So, but watch this. If I disconnect the charging and just leave the meter across the capacitor, watch the meter. It starts dropping pretty rapidly. So this capacitor isn't any good. It's a whole lot better than what it started off though. But when I first did this, that would be at 0 volts by now. It was discharging extremely quickly. I'll put that back on, and so you know, I guess at a pinch that could probably do. Nah, probably not. I'll have to check his ESR with that little meter again, so I'll do that. Testing with this little multifunction gizmo. Once again, electrolytics take a while. 3000 microfarads, so not the 3900, and still 1.9 ESR, which is way too high. So this capacitor is cactus and has to be replaced. Not worth putting it back in, even though it does show signs of life again. It's not worth putting it back in. It's too hard to get out, and it's probably not going to do its job very well. But it's only 3900 mic at 6 volts for, you know, okay, it's not huge, but it's not small either. I mean, that could be replaced with 2 of these guys, and they're 25 volts, and it's be even a bit more capacitance in less volume. But look at the terminals on that. They must be expecting some fairly high transient currents to come in and out of that. So I could use these, or use radial ones, brand new, dirt cheap, a lot cheaper than that. And I'd do that if I had no other choice, but I went looking through my huge collection of computer grade electrolytics from yesteryear. I found a few with the same diameter as that. That one, of course, is too long because it has to fit in. There's not much room beyond the length of that before the bottom of the power supply. So I could saw that down, of course, but that wouldn't look very nice, so we can't use him. Here's a couple that are very similar size. They could go in its place, assuming that there's enough clearance there, and there. Yeah, it's a much higher voltage job. That thing looked a bit permanent, and then I found this guy. Almost the same size, a little bit touch longer, but about 3 millimeters longer. 3900 microfarads, 20 volts, but a lot closer to this than anything else I've got, so I'm going to use him. Of course, this hasn't been used in even longer than that one, so I'll have to go through the reforming or slow power up on this one too, just to be sure that it's good. And this rotten clamp that was on him, I'll just replace with this one from him. Let's just have a quick look at this one on the little meter. 4176 ESR bugger all, so he looks pretty good. We'll go for the slow revoltaging, reforming process over an hour or two, and then I'll call that one good. Now, having a look at this board, okay, there's a lot of dust to clean off, but where this little capacitor was, there's a lot of corrosion on the PCB, so this board is going to have to come off to clean up all that munge. Not sure what caused all this. I guess maybe it was oozing from this. Can't really be anything else, can it? I'm not sure if there's any way for water to have got in there. So the board looks like it's got 1, 2, 3, 4 screws, but then there's this inductor. But fortunately, it seems to go into a couple of posts with Allen keys, so I should be able to loosen those under the screws and lift the board off. There's another couple of posts there for these wires. I don't know why. I suppose they can install the caps first and then install the board later, or make it so you can replace the board without having to replace the capacitors. Yeah, without having to undo all this, yes. You can just replace the board by loosening all those 4 Allen keys. Alright, so I'm going to get that board off. And there you can see the corrosion, and I'm starting to think it is water, because it's hard to believe some ooze from that would get this far. Hopefully that'll clean up alright, and plenty of dust on that. There's the inductor wires, dust and rust to clean up him. So let's get to cleaning that up and beginning to reassemble things. And there it is, cleaned up. CRC is pretty good at getting rid of rust, and then wash with isopropyl. And on the circuit board I've given a spray with that stuff. CRC is also good for the rust that was in the corner here, so it's mostly gone. So a little bit of corrosion on the tracks, but not too bad. So I'm hoping that if I put this back together with this, I won't have to be undoing it again. Hopefully there's nothing else wrong on this board. Time will tell. So I've untangled the white wire and that ribbon cable, and to give the ribbon cable a bit of strain relief on that connector, I've tied it to the loom there so that there's no strain on that connector. Okay, I've reformed the other capacitor and reinstalled them. And give you a few tips if you're ever going to do this. This plate and the 2 posts underneath it have to come out first before you take the capacitors out. You'll only damage them if you don't, and they go in last after the capacitor has been installed. Obviously you have to tighten the screws on this one, then slide in the second one and do the screws on him. because you need this to be over in this space a bit so you can get out without, if you haven't removed the inductor. Also, the capacitors have to be staggered like that because the power cable needs to come, it goes through there. It needs that bit of space there as it bends. I strongly suggest that you take a photo of how those wires are arranged. They're quite stiff and very hard to route, and yeah, I mucked around with it several times before I went back in the video and saw how it was done. This little capacitor, the two screws on the replacement one are a little bit closer together, so I've had to gouge out the holes on the PCB so that the screws can fit, which is fine. The other issue is it's a smidge longer, about higher, about two or three, maybe 3 millimeters higher, and when it's in there, it sticks it's a bit proud of that. So I could say stick washers underneath these screws, but the little countersink screws that hold them on are extremely short, so there's no room for washers really, and that would push everything a millimeter that way, which would impact on this board, which sits above it. And the reason they have plastic caps on those electrodes is because they already touch components on this board, so it's all very tight. It's much tighter than it seems. It's a bit deceptive. In fact, I'd really like to just rip all of those out and put in smaller modern ones, and it may yet turn out that they're stuffed anyway. But what I'm planning on doing with this guy is grinding off, well, almost down to that black, 1.5 millimeters, to give me the clearance I need so that I don't have to worry about trying to put washers under there. We'll see how that goes. And there it is, ground down. Took a bit of patience and fiddling to find the original thread, but away we go. Now I'll put them on there and see what clearance we get. Okay, the little cap's back on, and there is just not even a paper's thickness worth of clearance, but that should be okay. I don't need to muck around with washers underneath here to lift the whole thing up, I hope. In other news, while all that was going on, I got delivery of these mate and lock shells to put on there so I can connect some dummy loads when I finally get around to that stage of the proceedings. Right, now I'll clean up the rest of the box and put this back in. Removing the fuse gives access to this screw here, 2 more on the back, and that should get the fan out. Give him a clean. I may as well take everything off, then I can get, well, I'll see. It looks like it's only going to be these 4 more screws to get the whole rest of it out, except for a few bits of wiring, making things more awkward, but that's all one assembly. Yep, just got to undo that lug, and then I can get everything out of this case and give it a good clean. Right, transformers and that assembly's away. This thing's a bit of a bugger to undo, I think. I've had trouble with them before, so I don't think I'll bother. I'll just clean it up like that. Everything went back together reasonably well. That the length of that little blue capacitor doesn't seem to have been a problem. But I'm about to turn on, and I am very scared because I've done a lot of work there, and I just don't want to see a big puff of smoke as a result of it. I've got that sitting across what I believe is the 5-volt output, and okay, here goes. I hear a transformer buzz. No volts, we've got a buzz. It's only 13 watts, so nothing seriously wrong. The fan's not turning. Right, nothing. But no smoke either, that's a good sign. We saw no voltage coming out of there. The fans aren't turning because the relay hasn't picked. The transformer's running via a resistor, power resistor down in the guts there, that gives it a bit of power, but doesn't, until the relay is picked, the mains voltage doesn't go to the fans, and the rectified raw voltage doesn't, from the big capacitors on the back, doesn't get into the regulators. We can monitor the raw power supply, which is on the capacitors there, and if I wind up the volts, so there's the transformer buzzing through its resistor, 240 in, and we're getting 42 on the regulated supply. Now to actually pick the relay, we have to short terminals 1 and 3 on that power control connector. You can hear it trying to pick, but it's not enough voltage to turn it on, so we have to wind it up some more. Oh, it must have come on, the fan started turning. Okay. Right. The jumpers across there to pick the relay. So if I wind up the voltage till the fan comes on, then the relay's on and we're getting power into the regulators, and we should see some output here, which I believe is the 5 volt output from the main regulator. So winding the voltage up. There it goes. Relay ticked on. Fans are going. Nothing coming out of there. But there's no smoke. I'll turn up a bit more since we haven't got any smoke. Fan's a lot quieter too without, when it's being driven, sorry, the transformer's a lot quieter when it's being driven properly by the relay without going through a resistor. Airflow's right, so I've got the connections onto the fan properly. But nothing coming out of regulators. But no smoke either, so just in case it's waiting for the right voltage, let's take it all the way to 240. Right, we've got 15 on pin 1, 2, 3, 4, 5, 6. And there's 5 volts. That might be the 5 volt B that I think comes off this board. And there's minus 15. So they're looking good. It seems like this board might be working and the bottom board not. So the current state of play is, on this connector here, I can get plus and minus 15 volts, which comes from this MOS regulator board, as it's called, but no 5 volts, which comes from this module. Now, that module needs the plus and minus 15 volts coming in here. It needs the raw DC, obviously, from the transformer and rectifiers and capacitors on the back, and it also needs this clock signal. So I know that that's correct, but I'll check it again. I'll try and find these 4 things on that module, make sure they're getting there. So first up, turn it on. There's the 5 volts we're not getting. Now someone else had a restoration of a 1104 where they had very similar symptoms as this, no 5 volts, that the 3900 microfarad capacitor on the output of the 5 volts was also failed. I've replaced that, and they ended up finding that this thyristor here in the crowbar circuit was dead, which might explain that low voltage there too, if it's on and it's just gone into current limit. But I do want to check that it's getting the clock signal and those other things, make sure that's not it. Also, with that other example I just mentioned, with the dud thyristor, another symptom of that was that they weren't getting the full raw voltage on this C14, which is that guy there, big 50 microfarad. They weren't getting full voltage on that because of this dud rectifier, but I am getting full voltage there, so I suspect it's not the SCR, at least not at this stage. So I'm going to check those inputs are getting onto this board. So the first thing is the raw DC, which should be on those terminals there, because they're the ones that go through to the capacitors on the back. Right, 39 volts, which is pretty much what it should be. Plus and minus 15. They would come in, and the clock signal would be coming in on this connector from this board. And it's a bit hard to trace things out from there. The component overlay from the engineering drawings was pretty illegible. This one's actually from the engineering drawings for the 1134, but they both use the same power supply, so with minor differences the parts should be in the same places, and it's a little bit more legible. So plus 15 should appear on R26, and R26 is there. 15 volts there. Minus 15 comes in and goes to R16. And R16 is R16 is just right down this end here. Minus 15 volts there. So the next thing, the last thing to look at is this clock signal. And he comes in, should be visible on C12 or R39. R39 is there. So I'll try and scope that. Okay, we've got the oscilloscope set up over there now, and I'll try and probe that R39. Should be, I think, 20 volts peak to peak at 20 kilohertz. Okay, we have a square wave there of 20 kilohertz, and we're on 5 volts per division, so it's about 12 volts peak to peak. It's looking okay. So, if that's correct, then all the right signals are getting into this module. Why doesn't it stick out 5 volts? Just by the way, this by itself, just what it's doing is drawing 75 watts. I don't know if that's too much. Fan hammering away. And we'll try and work out what to check for next. So the inputs to this thing seem to be right. We've got the plus and minus 15 volts, and we've got the clock signal, but we're not getting 5 volts out. And we're putting in the 39 volts raw input. So suspecting I might have similar problems to the blog I mentioned before, which was from the Dator Museum in Sweden, where he found that the 3900 microfarad capacitor was a dud and the thyristor was a dud. The thyristor there. I'll just check the current across, the voltage across the current sensor resistor there, and see if it's drawing too much current, which would happen if the thyristor was shorted. And we've got 155 millivolts across a 10 milliohm resistor, which means it's drawing something like 15 amps. So yeah, that might be what the problem is. This resistor here, which is in the output path. If this thyristor is shorted, then would get a heavy current flowing. To see if it's gone into the current limit, we can look at the output of that op amp. If it's high, then the thing's in current limit. And I've got 8 volts, which means, yes, it's in current limit. So something's shorting the output. Could it be that capacitor I put in? Maybe I screwed that up. Maybe I overheated it when I ground down the terminals, because that did make it pretty warm. So I think what I'll have to do now is pull this out again and disconnect these guys, everything around there, maybe even that capacitor that I've replaced, in case I've stuffed that up. And because there's nothing else that could be shorting it, can only be those elements there. I'll do that, but I'll do it tomorrow. So I removed the power supply from the case. Before I did that, just with the MOS board off, I measured it across the output capacitor terminals, the resistance, and it came out as a hard short, not just the charging up of that little blue capacitor, but a solid short. So I've taken it out of the case now and removed the capacitor and checked the terminals without the capacitor there. No short. Check the capacitor, it's fine too. I haven't damaged it. It checks out okay on this, and it takes just a second to charge up by the multimeter. So then I thought, well, what's going on here? I plug it all back, and now we're looking at voltage, the 5 volt output. And 5 volts. So it's working. But it didn't work when it was all back in the case there. Not sure what's going on. I'm wondering if maybe my extra long capacitor is just putting a little bit of tension on something and causing a problem when it's bolted into the case. I'll have to look at that now. But curious, huh? I'll put the 5 volt regulator back in and the back panel back on there, and testing the capacitor across the capacitor. Just a short pulse as it charges in each direction. So we still haven't got a hard short anymore, which is making me wonder if when this is mounted down we get a short, because these rubber things here do press onto that board. I just wonder, so it's meant to make some contact. Maybe it's bending something, causing an issue. Let's have a look. Yeah, I don't need much of this mounting design here. That there is, it's held by screws at the bottom and 2 here, and there's slots. I can slide backwards and forwards, and there's quite a bit of tension on there because of parts of this pressing onto parts of that. Those large capacitors. It's almost tempting to just rip them out and put smaller ones in, but yeah, so I could push that in further and tighten it down and put even more strain on things, but I don't want to do that in case that's what's causing my problem. And I dropped a washer trying to get this mongrel thing on. It dropped in there somewhere. I cannot find it. I pulled it all apart, shaking the crap out of it. It's not on the floor. It's not in there. I don't know where the hell it got to. It's bloody annoying. But anyway, looking at the outputs, I'm still getting capacitor behaviour, which means that short is not there, at least for the moment. An unsatisfying result if you can't point to, that's what caused it, except the only thing I can put it down to is the sloppy design on this that allows great tension between these two boards. But anyway, I'll plug it in once more and see if we've got our voltages. Right, we've got our 5.1 volts. It's 5.1 on the output here, because it's 5.1 volts in a diode in there, and I suppose that allows for a 0.1 voltage drop over the wiring to the chips on that boards in the card frame. And other voltages, there's our plus 15, That's the plus 5 volts from this board for the battery backup. I don't know if it's used for anything. And there's the minus 15, so, and we've still got our plus 5. So that's working for now. It's a very unsatisfying result though. Well, we'll see how it goes. Because I don't know why that 5 volts came good, I'm thinking it's pressure on the MOS regulator board, but I don't know why. So as soon as I do anything, even just putting the cover on, I want to check that things are still working properly. So we'll have a look at that. Still at 5 volts. But I am not happy about that at all. I'm very tempted to just replace all the tall capacitors on that MOS board that are making it press down hard onto the 5 volt regulator underneath, to eliminate that as being a possible source of future problems. You can see the capacitor in here, silver with a black bottom, which is the cause of the problems. Because of that, this screw here is only just inside the slot. That board can't go down to completely sit into this, so the screw completely sits into the slot because of that bloody capacitor. In fact, there's 2 of them, and they've got a black rubber cover to stop them shorting out whatever they're pressing against, but they're pressing against it way too hard. Now that's a little bit worse because I put in that blue 3900 microfarad capacitor at the back, but that's only moved this stuff up 1 millimeter, and that's 4 or 5 millimeters at least too far into the bottom board. So I've decided I'm not having it. That's just ridiculous. I'm going to replace them. There's only 2. There's 3 others, but tall capacitors, but they don't interfere with anything. It's just these, just 2. So I'm going to replace them with something like these. They're 390 microfarads according to the parts list, but in the schematic they're marked as 560 microfarads. So I might even stick 1000 microfarads in there. They're the filter capacitors sitting across the transformer and output in this MOS regulator board. So they're sitting across the plus and minus 15 volts respectively. So I imagine 1000 microfarads won't be a problem in there. Might even be a benefit. Maybe they decided 390 wasn't enough and it should be 560. So more's even merrier, isn't it? Let's make it 1000. So that's the next thing. It's just ridiculous. So these are the 2 culprits here. You can see that they extend above the other highest point, which is these transformers, by 6 to 7 millimeters. So yeah, they've got to go. And I'm going to replace them with these lower ones. These are 1000 microfarads. So these are 560 microfarad 20 volts. The parts list says 390, but the schematic does say 560. Yeah, and I'm going to replace them with 1000 microfarad 25 volt, low ESR 105 degrees Celsius. And I've got 4 of them because I'm going to do the same thing in the PDP-11 34 power supply. These ones here, I've just strapped them together to reduce flappage. They aren't really a problem because they live in this area of the box where there's nothing for them to interfere against. But these guys are up against either these resistors, this transistor, or possibly even that terminal there, and it's pressing hard against it. So with these there's at least probably 3 or 4 millimeters clearance if they're the highest points. So getting rid of these I think is very much worth doing. There we have it, finished. Plenty of room now. We've got a good 6 or 7 millimeters more clearance than we had before, which should allow these slots to drop fully down onto the bolts that hold it to the heatsink there. Right, there it is fitted. You can see that the bolt here is sitting well inside the slot. It's not at the end, it's fully covering this heatsink. I could push it down further, but there's no need, and we've got at least 2mm clearance in there between the transformer and the transistor. So now all I have to do is turn it on and see if it still works. Right, with the cover fully restored, let's check all the voltages. There's our 5. Plus 15. That's the plus 5B. Comes from the MOS board, not the main regulator. Minus 15, a little bit low. But that's using the new capacitors. And the next thing to do is make some dummy loads to plug into it and see how it works under a bit of stress. So I've wired up this connector to make a dummy load test harness. First off, I'm just going to do the plus and minus 15 and the plus 5B with these resistors. Turn on the power. 4 5.6 ohm resistors in parallel, making 1.4 ohms, which will draw from the 5 volt supply, which is here, 5 volts, not the main 5 volts, the plus 5B, which comes from the MOS board, not the main regulator. Just watch the ammeter there. This voltmeter is not doing anything. Should get about 3 or 4 amps. That should give us 3.6 amps actually, that load. Put it on, and according to that meter, I don't know how accurate it is, we're getting 3 amps. Then we have a slight voltage drop. Take it off again. 5.09 down to 4.95. Off. On. On. Off. So I think that's probably pretty good. Now for the plus 15 volts. Well, then we have 3 47 ohm 10 watt resistors in parallel, making 15.6 ohms, which at 15 volts will draw 0.96 amps or 14.4 watts. And these plus and minus 15s are rated at 1 amp, so we're drawing almost their maximum. So connecting the ammeter to this, we should see about an amp below there, about an amp, and he's still above 15, doesn't drop much, it's pretty good. And the minus 15 here, again 3 47 ohm resistors in series, parallel, and we're drawing an amp, but it drops a bit more, that one, doesn't it? 13.6 from 14.79, so it's dropping more than a volt, whereas the other, the plus 15 dropped only, what, a tenth or a fifth of a volt or something. So yeah, minus 15 is not as up to the load as the plus 15. Again, does it matter? I don't know. I'll call it good enough for now. Okay, now I've got to wire this up permanently and then put a load on these. The 5 volts at 25 amps. So there's the load for the plus and minus 15 and the plus 5B supplies, semi-permanently. I might actually make up a circuit board and mount that all very permanently. Turn it on. 116 watts. If I unplug the dummy load thingy, 46 watts with these three supplies being loaded up almost to the limit. Now it's only 95. Why is that? Only one of our supplies dropped out. Plus 5B. No, not there. Minus 15. Plus 15. But the minus 5B isn't. Maybe it doesn't like being plugged in while the power's on. And now we've got our 116 and we've got our 5 watts. So it doesn't like being plugged in while the supply's running by the look of things. Well, then we won't do it while the supply's running. As a dummy load for the 5 volt supply, I'm going to use this, which is a whole bunch of 50 watt 12 volt halogen bulbs that I can wire any which way on the back here. I've done a video on this thing, but by looping these things around or putting various jumpers like this everywhere, I can set up all sorts of different loads. So what I'm trying to do here is get about 25 amps. First of all, I'm just going to stick 5 volts across one bulb and see what current it draws. It'll be more than 5/12 of what the bulb would draw at 12 volts, because having a very high positive temperature coefficient, the resistance of the bulbs is much lower when they're cold, and 5 volts will never get them up to the 12 volt operating temperature, so it'll always be significantly lower resistance than when it was running off 12 volts. So we expect, not sure, let's just have a look. We're drawing about 3 amps at 5 volts. So if I put 8 of those in parallel, that's 24 amps. I'll start wiring that up. I'll put 4 off these two and 4 off these two. Okay, I believe I've wired the 4 corner bulbs there all in parallel and running off one pair of 5 volt lines through the ammeter. So that should be, if they're 3 amps each, that should be 12 amps. We should see that there, and if that's correct, then I can do the same thing with these 2 wires over here to make 24 amps. So let's turn it on and see what happens. Whoa, 10 amps, well, that's pretty good. Notice the wild fluctuations. That was because these things have a very low resistance when they're cold, so we get huge currents. I'm surprised it didn't trip out, or maybe it did, that's why it fell down. Might need something to limit the current initially. Maybe run it through a 5th bulb and then short that bulb out once we've got a bit of temperature. Not sure, I'll work it out. I'm going to try that again without trying to avoid the huge current surge when the bulbs are warming up. So I'm going to do that with in series with one bulb, and then short out that bulb once we've got a bit of temperature on these bulbs. Let's see how that goes. Yeah, just a kick, and this bulb lights up. Now that we've got a bit of current flowing, we can short out that limiting bulb. Not quite as bad a kick, and 9 amps. Alright, I'll wire up the other side and have a think about the best way to do this startup stuff. Rather than trying to run a current limited startup and then short it out, I'm just going to wind the incoming AC voltage up so that there's no sudden surge when power is first applied. So turning up the volts, we've got to get to at least 80. It doesn't like that, does it? And this is it. Stabilizes at about 140 volts input, so taking it up to 240 now. There it is at 240. Okay, we haven't got our 24 amps, but bloody hell, that's good enough. Now I want to see that we still have 5 volts coming out, and we've also got those other loads on the plus minus 15 and the plus 5V B, 4.93 volts at a wobbling 18 amps. Something's loose. 18.5 amps, 4.93 volts, plus this lot. All getting nice and hot. So this isn't ideal, but it was something I could whip up pretty quickly. And total current power consumption is 300 watts. I think that does it for testing this guy. But while all this power supply stuff is still fresh in my mind, I think I won't go any further with the 1104 and just do all the same thing I've just done here with the 1134. Make sure its power supply is good. That's about it for this video, I think. Hope you found that interesting and enjoyable. If you did, please give it a thumbs up and subscribe for future episodes. Catch you later.